Hi everyone. Hello, how are you? How are you? Okay, last class I just completed. I just started the biomolecules, the new chapter. Last class I just started what is carbohydrate. That means basic things of the carbohydrate. What is carbohydrate? What is the general nomenclature of carbohydrate? What is the modified definitions of carbohydrate? That stuff I already discussed. Now, what do you mean by monosaccharide and the reactions of glucose? This part completed, as well as structure of glucose. That stuff also completed. So just write down the chapter name, which is a biomolecule. So for biomolecules, if you write down this one, last class I just completed the structure. So just started from this revisions of last one, structure of glucose. Now the structure of glucose, first one, if I have to know what is the cyclic structure and what is the open chain structure. So if you draw the open chain structure, open chain structure which can be represented like this way. OH, OH, in this case OH is present, here also OH group is present, HH, this one is CH2OH. Okay, now if you write down, if you take this one, this carbon, this OH group, that means whatever carbon which is directly attached with CH2 group, at this particular carbon OH is the right hand side. That's why we can write this one is the alpha glucose. Now look, this diagram, this CHO stuff, you can draw like this way. Now tell me, what is the hybridization of this one? Hybridization of this one is a sp2 hybridase. So this lone pair electron can attack at this particular position. That means sp2 means planar, so it can attack above the plane. It can also attack. Another possibility is it can also attack below the plane. So two possibilities are there. Now if you go through the above the plane attack, then you get this one. Another structure. If you draw the structure, the orange one, what will be the structure? COH, OHH, OHH, OH, H, and this oxygen is directly attached with this one. Okay, CH2OH. Now sp2, so another possibilities are there. H, similar structure, the other stuff is basically similar. OHH, and another case like attack like this way. Okay, now these are the structure. Now what you know, that if this carbon, this particular carbon which is called as a anomeric carbon, this particular carbon which is termed as a anomeric carbon, now at the anomeric carbon OH group is the right hand side, here OH group is the left hand side. That's why if OH group is the right hand side, we can say this one is a alpha D glucose, this one is a D glucose, sorry, D glucose. D glucose is happens due to this OH group. This OH group means this carbon, this CH2 group is associated with this particular carbon. This at this particular carbon OH group is the right hand side. That's why this one is a D glucose. Now this carbon which is known as the marked carbon which is known as the anomeric carbon. Anomeric carbon is a carbon where nucleophile attacks takes place. Okay, anomeric carbon. Now at the anomeric carbon OH group is the right hand side. That's why this is known as the alpha D glucose. Here OH group is the left hand side. That's why this is termed as a beta D glucose. Okay, and this one is a cyclic structure of glucose. If you write down, this two is basically represent the cyclic structure of glucose. cyclic structure of glucose. Okay. Now, next case we can explain like this way. In solution case, basically glucose exists as a open chain structure as well as two cyclic form, both are exist. So can I write in solution phase? In solution phase, D-glucose which exists as a alpha form as well as it is exist as a beta form. So basically alpha, beta, D-glucose, these three form can possible. Okay. Now just write down what from here, how can you explain the cyclic structure of glucose which is proposed by Howard. So again, next part is cyclic structure of glucose. Cyclic structure of glucose which is developed by Howard. Developed by scientist Howard. Okay. Now for Howard case, always remember, how can you, in this case, always remember this glucose always exists as pyranose form. Now pyran is looks like this way. This one is a structure of pyran. Okay. Now remember one thing, for pyran structure and Fischer structure, if you draw Fischer and Howard structure, those group which is present right hand side at the Fischer structure, that means open chain structure, it is exist as a below. Okay. Those group which exist as a left, which is in our structure, this is actually above. So basically you have to check this one, you have to check this one is a Fischer projection. Now from Fischer projections to our projection, how can you draw? Look, in this case, if you draw this one, in this case, where the numbering start, oxygen, after that second one, 2 3 4 5 6. So 6 numbering gets from. Now what is, which carbon is the anomeric carbon? If you go for the nomenclature, if you go for the numbering for nomenclature, this white one is basically numbering for nomenclature. This anomeric carbon, this particular carbon where the sp2 carbon are there, this is a carbon number 1. So for glucose structure, we can say carbon number 1 should be the anomeric carbon. Now how can you draw the Fischer projections? Always remember, for Fischer projections, just draw 6 member ring first. Okay. Now you have to go clockwise method. That means oxygen I am taking number 1. That means number 1, number 2, number 3, number 4, number 5, number 6. Now number 2, if you take alpha D, I am trying to draw alpha form, alpha D glucose. Okay. Now at alpha D glucose, if you check the alpha D glucose structure, this OH in the right hand side, next right hand side, and right hand side means always, if you draw right hand side is always in below. So this one is a below form. Again, this one exists as a below. Next one exists as the upper part because it is exists as a left. Again, this one exists as a, if you check this one, that means 2 3 4, then 5 fifth one. If you check, what is the form? Fifth one, OH is again right hand side. Sorry, 1 2 3 4, fifth one. In fifth case, basically oxygen attack. Just a minute. Sorry, this one. So this one is a 1 2 3 4 5 6. So at fifth case, OH is basically right hand side. So at fifth case, if the OH is the right hand side case, always remember where it is happening, below. Okay. Now last case, always remember this is always in above, CH2OH. Okay. So this one basically the alpha form. Now at beta form, at which carbon this is changing? This carbon, which is anomeric carbon, at only the anomeric carbon, OH and hydrogen position are changing. OH becomes upper, hydrogen becomes lower. So this one is the anomeric carbon. Now at anomeric carbon, how can you draw this one? All the things remain same. All the things remain same. Only the anomeric carbon. Only the anomeric carbon placement of OH and H group is changing. Others, all the stuff same. And this carbon which represent anomeric carbon. Okay. Okay. So this one is a beta form. Now tell me, this one is a beta form. What is the relation between alpha D glucose, beta D glucose? If you write down this one, we can write alpha D glucopyranose, because this one is a pyran form. So just write down what is the name of this one. This one, which is called as the alpha D glucopyranose, and this one which represent beta D glucopyranose. Pyranose. Okay. Now, what is the relation between alpha and beta? Always remember, alpha and beta both are anomer with each other. So, alpha and beta glucose are anomer with each other. With each other. Okay. Now, what is the definition of anomer? If you write down the definitions of anomer, anomers. What are the definitions of anomers? Now, anomers are the diastereomers. Just write down. Anomers are the diastereomers. Diastereomers in which configuration of atoms. Configuration of atom. Configuration of atoms. Configuration of atoms around anomeric carbon is different. Anomeric carbon is different. Is it clear? So that is the end of glucose part. Then we are moving to another monosaccharide, another important monosaccharide, which is fructose. So just write down fructose. Next is we are moving to fructose. Fructose. Now, what is fructose? Fructose is C6H12O6, which is fructose. Now, what will be the molecular mass? Molecular mass is 180. Okay. Now, always remember glucose and fructose both are functional isomer. Now, what will be the structure? Now, look, the structure is not possible. Again, scientists take some reagent, then they react each other. After several reactions, they decide the structure of fructose. They just predicted the structure of fructose. Now, after development of technology, they find out this prediction will be correct or not. Then after that, they get exact structure of glucose. Now, what is the history that you need not to write? You need not to learn. Now, what are the reactions by which glucose structure was determined, that you have to know. Now, if you go for the fructose structure will determine, that you have to know. Now, look for fructose case. Its structure looks like this way: CH2OH, C double bonded O. Next carbon, next is basically OH, H, OH, OH, HH, CH2OH. Is it clear? This is about the fructose case. Any doubt? This stuff is clear? Okay. Now, in this case, which one? This one is a sp2 carbon, so nucleophile can attack takes place at this particular position. Now, what are the basic reactions if you go for the basic reactions of fructose? First reaction, when it react with NaBH4, from BH4, basically H minus can attack, this bond comes here. And this part I am taking as a R. Okay, so what you get? You get COH, CH, 2OH, H and R. Now check, this carbon is a chiral carbon, so different form is also possible. No, now different form is also possible. Now if you go for the bromine water, now for bromine water, no reaction takes place from here. Remember, if you go for the glucose case, CHO bond gets oxidized. Bromine water, why here reaction not takes place? Because bromine water acts as a mild oxidizing agent. Mild oxidizing agent. Okay, this one acts as a mild oxidizing agent. Now when it want to react with red phosphorus with HI, again the hexane reaction takes place like glucose. When it react with HNO3, which is a strong oxidizing agent, this 1 degree and this 1 degree, 1 degree alcohol can reduce after reduction. We get this one COOH, C double bonded O. Other stuff remains same, like this way. This one converted to COOH, like this way we can write. Okay, now look, if you write down, this one is a beta, this one is a acid group, after that COO group. Okay, after that COO group. So in this case, if you write down, COO group is just below the COO group, that means carbonyl group, which is just below the acid group. So if this one is a alpha, this one is a, I am taking beta, so we can say this one is a beta keto acid. Now when you heat it, for beta keto acid, heating effect takes place, carbon dioxide eliminates. So after elimination of carbon dioxide, we can write CH double bonded O, OH, H, OH, H, OH, H, COOH. Now look, in this case, what is happening? Basically, in this case, one carbon. So in this case, we can write one carbon decreases. Okay, is it clear? Now when it react with acetic anhydride, similar type of reactions takes place, where free OH group is present, here, and the uppercase. Free OH group converted to OAC group. So can I write CH2OAC, C double bonded O, HOAC, OACH, OACHCH2OAC. Okay, now remember only one case. What is the distinguished test between glucose and fructose? If you write down this one, bromine water, which can react with glucose but not react with fructose. So just write down this point also here. Bromine water act as a distinguished test. Distinguished test or distinguishing test to distinguish between glucose and fructose. Very, very important line. Very, very important line. Just remember this part. Okay. Do you have any doubt? This stuff is clear? Okay, so then definitely in some cases fructose reactions not takes place. So definitely here also cyclic structure of fructose is possible, like as glucose. So just write down next part, which is a cyclic structure of fructose, like as glucose. So just write down cyclic structure of fructose. Now cyclic structure of fructose, if you write down. Okay, now how can you draw this one, cyclic structure of fructose? Just a minute. Now first we are try to draw normal open chain form. Open chain form already discussed. CH2OH. Okay. Now at this particular case, we know this one is a SPT, SP2. SP2 means planar. So attack can possible above the plane, below the plane. So in this case, this one D or L form, CH2OH, next carbon, OH is the right hand side. That's why this one is a D form. Now in this case, what is happening? This lone pair can attack top of the site. It can also attack from the bottom part. So two possibilities are takes place. Now, if you draw the two possibilities, first case, if you draw the first one, what is happening? Look, COH, CH2OH. Okay. Next case, OH, H, OH, H. This O combined with this one. Okay. Now tell me, this one is the alpha form or beta form? Which carbon is the anomeric carbon? The sp2 one. So at the sp2 carbon, this OH is the right hand side. That's why alpha D fructose form. Okay. Now if you draw the beta D fructose form, how can you draw? Similar type of structure will possible. All are in equilibrium conditions. All are in equilibrium condition. Now similar way, OH is basically left hand side, CH2OH, OHH, OHH, OH, CH2OH. Okay, you can draw. Now tell me, in this case, how many member ring gets formed? Number one, then number two, number three, number four, five. So in this case, basically 5-member ring gets takes place. Now here, check OH. This carbon is the anomeric carbon. OH is the left hand side. That's why this one is a beta D fructose form. Okay, this one is a beta D fructose form. Now again, you have to draw cyclic structure with the Howard position. So just write down next one, which is again the cyclic structure of fructose, but the Howard position takes place. Cyclic structure of fructose, but Howard position. Now, if you draw the Howard projection stuff, what will be you have to select? Suppose this one is a O, this one, which is resembles like furan. So this one we can write resembles like furan. So this form you have to told furanose form. Okay. So again, similar theory, Fisher projection and Howard projection. Those who are in left right hand side, below, those who are in a left hand side above. Okay, now this form we can write furanose form. Furanose form we can write furanose form. Now how can you draw this one? How can you draw this type of structure? If you draw this one, first draw the furanose form. Again you have to draw the clockwise. I already told you clockwise. So which one is a, now tell me one thing, for fructose case which carbon, if you go for the normal open chain IUPAC step 1 2 3 4 5 6, now which carbon should be the anomeric carbon? So carbon number 2, which becomes the anomeric carbon. So just write down this one represent anomeric carbon also. Now in this case, O, next carbon, second carbon. For second carbon, OH is a right hand side. Right hand side means left. So just draw this one. OH becomes left. CH2OH right top. Then OH top. OH H. Then check HCH2OH. You can check this one. Second carbon. After that, we have to move third one. For third one, OH is a left hand side. Fourth one, OH is a right hand side. That's why like this way. Is it clear? This one is a alpha fructose form. Alpha D fructofuranose. You can write furanose. Okay. Now what will be the beta structure? Only this. Which one is the anomeric carbon? This one represent the anomeric carbon. Only this anomeric carbon position are changing. So if you dot the beta form, similar structure, only this position is changing. Okay. Now just draw the anomeric carbon. This one is the anomeric carbon. Write down this way. This one represent the anomeric carbon. Okay. Now carbon number 1 for glucose. Which is anomeric carbon. Now carbon 2, anomeric carbon for fructose. Okay, is it clear? Any doubt? Glucose and fructose stuff clear? Now we are moving to the next part. Giving you one question, try to solve it. Tell me the answer quickly. Quickly. Done. This one completed. Look, first case. This OH lone pair can accept this one. Next step. This OCH3 can attack at this position. This bond break. So how can you draw this one? CH2OH. Next step, OCH3 takes place. This one OH. All the step becomes same. So whatever reaction which is takes at the anomeric carbon, remember, whatever reaction which takes place at the anomeric carbon, and remember what you get in this case. If this one is a aldehyde, then we can say hemiacetal. This one is a ketal. If this one is a acetal, then we can write hemiacetal if the aldehyde group is present, but this compound which is hemiketal, because this group is a ketone group. Any doubt? This one is clear? Okay, do you have any doubt? Next, we are moving to the muter rotation stuff. What do you mean by muter rotation? Why the muter rotation takes place? So just write down next part, which is muter rotation. Now, muter rotation takes place. Why the muter rotation takes place? Suppose this one is a alpha D glucose. Alpha D glucose present. Now, if you passed plain polarized light over here, this one is a PPL, not Pakistan Premier League. Remember, PPL, which is called as a plain polarized light. Now, what is happening? After passing plain polarized light, this light is basically deflected like this way. Okay. Now, what will be the angle in this case? When you did the polarimeter, theta near or equals to 112 degree, no, 112 degree something value is present. I am just taking a round of value. Okay. So this value is an experimental value, mental value. Okay. Now, instead of alpha D glucose, if you take beta D glucose, what is happening? Suppose this solution which contains beta D glucose, which contains beta D glucose. Okay. Now, again, you are passing plain polarized light over here. Again, this plain polarized light can rotate. And here, angle of rotation by measurement, you get near equals to 18 degree. So in this case, theta equals to 18 degree. This is all our PPL. Okay. This value is a experimental value. Okay. Now, what do you mean by muter rotation? We all know that at solution phase, alpha, beta both are present and both represent equilibrium. Okay. Now, if you take in this container, if you take at first, if you take 100% alpha, so beta value is 0. When t equals to 0, after certain time, suppose alpha changes to 90%, beta changes to 10%. Now, alpha when changes to 90%, we can say theta value definitely less than equals to 112 degree. Now, how can you find the theta value? 90% of 112 plus 10% of 18 divided by 10. From here, you just get theta value. You just get theta value. Now, how much time this rotation takes place? Till this rotation takes place when alpha beta till not becomes equilibrium. When alpha and beta forms equilibrium, in this case, this rotation will be stopped. So here alpha and beta when formed equilibrium, then this rotation will be stopped. And at this particular time, theta value when measured, its value becomes 57 degree. Now 57 point something is given. Just remember as a round of value. So what is mutual rotation? Mutual rotation is basically change in rotation when when glucose solution, if you taken in a solution, change in rotation of alpha glucose as well as beta glucose, this change in rotation is called as a neutral rotation, and neutral rotation happens up to that part when alpha and beta did not get equilibrium. After reaching equilibrium, this neutral rotation will be stopped. So just write down the definition of neutral rotation. Okay, it is the change in optical rotation. Optical rotation of a sugar solution. Sugar solution with respect to time. Okay, now mutual rotation only possible. Mutual rotation only possible up to when alpha beta are not in equilibrium. Are not in equilibrium. Okay, and remember, due to mutual rotation, at least two cyclic structures should be possible. At least two cyclic structure required. So just write down mutual rotation only possible when at least two cyclic two cyclic form can possible. Okay, so that is about the mutual rotation. So today's class, just go through the recap of today's class or whatever. Biomolecules I already completed. Biomolecules I already started from what is the general formula for biomolecules. General formula for biomolecules is CxH2O whole to the power y. Now this stuff is not possible for all the biomolecules. For biomolecules compound, you can go through like this way. Suppose if you go for acetic acid, formaldehyde, it can also follow this one. So what will be the modified definition of biomolecules? 5 point you have to remember. Chiral center should be present. POS, COS should be absent. Okay, POS, COS should be absent. Chiral center should be present at polyhydroxy group. At least one aldehyde or one carbonyl group should be present. Another case, always remember, must be optically active. That is about the modified definition of carbohydrate. Now next case, we just dealing with the what are the classification. Now classification of carbohydrate on the basis of reducing sugar and reducing character, and another is on the basis of number of sugar. Now if you go for the what is the synonyms of carbohydrate? Saccharide. If one sugar unit present, monosaccharide. 2, 3 to 10 sugar unit, oligosaccharide. More than 10 means polysaccharide. Now I already told you an example. Suppose Rama is a student. Each and every alphabet represent monosaccharide, particular word represent oligosaccharide, and the sentence which represent polysaccharide. Now for the monosaccharide case, glucose is important, fructose is important. Basically glucose and fructose are the fundamental units. These two are the fundamental units. Now if you go for the terminology stuff, terminology, it can be classified into three parts. First is which functional group is present. If aldehyde present, aldose. If ketone present, ketose. Now if number of carbon is 3, then you can say triose, 4 tetraose, 5 pentaose, 6 hexaose, like this way. Now if the based on suppose 6 carbon with aldehyde group, so we can write aldohexose. 6 carbon with ketone group, we can write aldoketose. Now glucose, how the glucose structure will formed after getting certain reactions with certain reagent, scientists develop the glucose structure, and glucose structure which is exist as a open chain as well as two chain form. Now chain form case mainly it exists as a alpha D form as well as beta D form. Now Howard projections, from Fisher projections to Howard projections, I already told you. Anomeric carbon is basically the sp2 carbon what the nucleophile attack takes place, that stuff completed. Now we are moving to the fructose. Now what are the reactions of fructose, already completed today's class. If you go through the previous lecture, you can say important thing, just remember bromine water is a particular reagent which can distinguish glucose and fructose. Okay, after that, normal open chain structure of fructose completed, cyclic structure of fructose completed, next Howard projections of fructose completed. Now just completed the mutar rotation. Mutar rotation is basically change in optical rotation with that, with respect to time. Mutar rotation only possible when alpha beta are not in equilibrium. When equilibrium achieve, no mutar rotation takes place. Okay, next class we will deal with reaction, oxidation reaction with HIF. Okay, till then, bye bye, take care, bye.